Good morning, everybody, and welcome to Oxford Future of Major Programme Management Conference 2022. My name's Guy Ainsley, and I'm going to spend the next 15 minutes or so with a very brief introduction to what we'll be covering today and tomorrow and Thursday. So we've picked these images. Why these images? And everyone can go to Photoshop or to Shutterstock and just get some images that exemplify major programs, and we chose these two. And to some extent, they're cliches, but when you look at them in detail, they uncover a number of themes that we're going to discuss in the next 3 days. One is the transition, the one on the left, as I look at it, the transition from the old to the new, so energy production in this instance. And the other one is a little bit more detailed, but it also exemplifies major programs being done to people, being overlaid on top of existing infrastructure. In this case, a road which layers on top of other roads, which probably layer on top of other roads as well. So we chose these images for two distinct and different reasons. Even though the one on the left is kind of a cliche of future thinking, the other one exemplifies challenges that are with us today. So what's the purpose of this conference? Well, purpose number one is to engage and re-engage. Who with? So academics, practitioners, policymakers, alumni, students. To collectively develop, and what we're trying to do is develop novel ideas and perspectives, research contacts amongst people who attend, and opportunities to take stock and reimagine the possible of major programs. What is it major programs can do for us? Purpose number two is to extend the scope and dimension of major programs and their management. And we're going to do this by exploring the cutting edges. So the themes of the next 3 days are really about taking our understanding and our thinking about major programs right to the very edge of where they currently are. And Daniel is going to spend a lot more time this morning talking about this. The third conference purpose is a call to action. So we are active, obviously, as a group of people, as within the business school and as a community involved in major programs. But we want to have continued and intensified engagement with everybody who attends the next 3 days. We want to think about and stimulate ideas for great research. The past couple of years have thrown up lots of opportunities for research, but have also stopped a lot of research happening because people have been focused on getting through. So now is an opportunity for us to put ideas on the table and go out and find people to engage with for those research ideas and hopefully get some things underway. The third call to action will be about application. There is no point talking about these things, about major programs, unless they are applied. So it's essential that we get a call to action across 3 areas: more engagement, research, and application. So I'm just going to very briefly show you a condensed version of what we'll be covering. Today is about defining the cutting edges. And Daniel's going to come on in a second or two and do a real keynote on the future of major program management. We're then going to have a break for 15 minutes or so, and then we're going to have a panel. Panel theme is bringing in the edges, and we're very pleased today, tomorrow, and Thursday. We've got some fantastic panels together. A really good blend of academics, practitioners, and students as well. Then Mark Ventresca is going to join us later on for a closing review. Day 2 tomorrow is going to cover the social cutting edge. So we're talking really about extreme operating environments, but we're going to introduce ideas and themes about the social impact of what we do. I would point out that tomorrow's session starts at 4 o'clock UK time. The reason why we're doing different start times is to capture a global audience as best as possible. We have a really exciting and very engaging, hopefully very engaging keynote from Larry Woods, who's the Dean of Blavatnik School of Government. We're also going to have a panel tomorrow about social cutting edges, excuse me, and then a closing review later on. From a professor of organisation impact and the academic director of the Skoll Centre, excuse me. On day 3, We're looking at the technological cutting edges, and this is leading big science. We're very, very pleased to be joined by Wendy Akolo, who is from NASA. We're then going to have a panel on technological trends and the technological cutting edge. And then we're going to have a bit of time tomorrow on Thursday afternoon talking about the closing review and reflections as well. And we're going to finish with a call to action. A couple of words about administration. We're using a system called Hopin, which you've all used to access the session today. And in it, you'll see home, about, speakers, and schedule, and there's lots of things you can do within Hopin. It's very self-explanatory, famous last words, but hopefully you'll be able to engage with each other and form connections within Hopin. The schedule and speaker bios are all there as well. We obviously run the MSc in Major Program Management here, and we're very pleased that we have 3 sessions, they're drop-in sessions, which run parallel to the timetable. If you want to talk to our recruitment team about the MSc in Major Program Management, you can access it through Hopin. And today's session, for example, I think is at 10:15 to 10:45. So if you are interested, please do interact with the recruitment team there. There are speaker bios, which is done alphabetically by surname, and that's why mine's the first. Apologise for that, but they're really interesting. And as I said earlier, we have fantastic panels that have been put together for the 3 days, and the speaker bios for these people, for the participants are there. Please do look at them because they are fascinating. So on to the conference, and this is the final sort of section from me. I'm very, very pleased to introduce Professor Daniel Armanios. Daniel's just recently joined us, and there's 3 pages of a fantastic cut down bio, which he said, "Oh, don't go through these couple of pages," but I'm going to anyway because it's well worth it. Daniel's bio is fascinating because it's a blend of engineering and social science, which of course is fascinating from a major program point of view. So you can read it yourselves there, and it does go on for 3 pages of this, which is brilliant. And I say this is the abridged version. But what is fascinating? Sorry, just go back 1 slide. Sorry. What is fascinating is it says there, Daniel integrates civil engineering and organisational theory to better understand how organisations coordinate to build, manage, maintain, and deploy infrastructure amidst complexity, and that really exemplifies the massive challenges that major programs face. Interesting, Daniel has current projects, and one of the things that really appealed to me is supporting the safe testing of breakthroughs. This comes back to the point about having people having major programs done to them, and I think it's always important, obviously, to be able to make sure that what we do within major programs, it will impact people, but making sure that their needs are taken consideration. That's it from me. So I'm just going to hand over now to Daniel. Thank you very much indeed.
Thank you guys so much for that kind introduction. I'm Daniel Armanios once again. I'm the BT Professor of Major Program Management here at Said. And it's my job to hopefully get you excited and start on this wonderful journey we'll have for the next couple of days. So I thought I'd begin by starting with the features of major programs. So we have kind of an academic view in terms of the kind of concepts and conceptualizations we use to actually characterize major programs. And we can think of them, just so all of us be on the same page, large-scale projects that entail multiple complex stakeholders and organizations, as well as ambiguous inputs, timescales, and outputs. It's unclear what goes into them sometimes, how long they take, and what's delivered. And there's also a practitioner view, which is projects that are over $1 billion, 1 billion pounds. I put a question mark here because as we unravel or unpack today what major programs are, we're going to have a sense, or we're going to have to think about whether 1 billion is the right metric. How is it measured? For example, there's quite a few digital projects that don't reach that kind of metric, but are highly complex, that affect millions of lives and often take even not just 5 years, but 10 to 15 years to build. And often, as we'll notice, for many of you that run major programs, the people that start the project don't necessarily end on it. And so a part of our work in major programs is building structures in place that can help routinize or continue the project going forward, even as people transition away from them. And so I'm going to use the same kind of imagery that Guy brought up in the beginning as a jump off point. I'm using this as a platform to think how we can think differently about these projects. Because usually, historically, the prevailing view has been major programs as some colloquially call mega projects, major infrastructure projects such as nuclear plant facilities, bridges, roads, and the like. So in the next few examples here that we bring up, I want you to ask yourself, what do you see, or do you recognize these as major programs? And then secondly, what challenges and opportunities do they provide to major program managers such as yourselves in the audience or those who study them? So we'll start with the company Icon. So Icon was a firm founded in 2017, and they built the first permitted, at least in the US, but they believe also globally, 3D permitted house in Austin, Texas. They then printed an entire community in Tabasco, Mexico, and they've started using several space and military applications because of the way you can tailor printing as well as deploy them quickly. There's a lot of interest in kind of using this for space applications, for kind of simulating the Martian environment, or creating new lunar crafts, as well as military that you can actually deploy quickly. By the way, I do have subtitles underneath for those who may be hearing impaired or English may not be your first language. We want to make sure that we're as inclusive as possible here. The valuation of this company is about $2 billion US. It's only a 5-year-old company. To give you a sense of what they've done, here is the first home they printed. This took 48 hours of print time. The foundation and the walls were what was 3D printed. The finishing, such as the windows, the roofing, the plumbing, was still traditional build. 1 year later, they were able to get this down to 24 hours for 500 square feet. The mortgages for this community were $20 a month for 7 years. This is a community that lives on $3 a day. So this actually was able to hit the price point of this community. Now, when we usually do novel innovations, we often, especially new companies that are trying to envision what's possible, it leads to the first theme I want to bring up today, which is scaffolding. They often will demonstrate or build a model project for you to understand how you can use that technology. And so here is the model project of Icon called House Zero, which I will narrate here. So this is the finished house. And this was to give you a sense of what you could do if 3D printing was the basis of your construction. And what we'll see in a minute here is the foundation will be shown. This is the foundation. They use a machine called the Vulcan, and they print using a proprietary substrate called lavacrete. Essentially, it's concrete with some additives to allow for printing. And you can see the kind of curvature, the kind of layering that's possible with this technology. You can see how it's printed. And for those of you who spent time in the construction industry, these kind of curvatures, these open spaces are not trivial to do. And so you can see that here. And there's currently additional 4 houses in which people are living and purchase them for their main living space. Let's move on. So another company I wanted to bring up is Zipline. It's a point-to-point drone venture. It predominantly works in Africa, namely Ghana and Rwanda, as well as Tanzania. It's often used currently for delivering critical medical supplies. So for instance, someone is injured in a rural remote area, they can find their blood type and ship that blood via payload via drone. And they're now working on agriculture and livestock. This company is also valued at around $2+ billion. To give you a sense of how this works, different drone technologies have different launch mechanisms. This actually uses a launcher, and then they drop the payload into the area of need. And the final trend I want to bring up as we talk further is around the portable renewable energy movement. So this is a company called Shine. This is literally a wind turbine in your backpack. So if you go camping and elsewhere, you can actually take that technology, put it in your backpack, set it up in 2 minutes, and it charges up to 4 different devices. It can have a power output of about 40 watts. And so really portable, in your pocket kind of renewable energy. Let's say this is not what you need, but you need something bigger, and you see the power ratios here are bigger than any other kind of renewable. Well, let's say you need more power. Let's say you need on the order of 200 watts. This is a company, Power Blocks. They actually have a solar system all in a box. They have the panel connected to the battery to the charger, and it can even be stacked up like Legos. But let's say you even need more power. Then you could go to Uprise Energy. They have a 10 kilowatt wind turbine that can come to you via trailer, and they can be set up on the fly. And they're developing a 50 kilowatt power generation system. So quite decentralized, quite distributed kind of energy. But this presents different kinds of challenges. So some of my work is in the Arctic, in Alaska. You do not need to read the text here. The text here is simply to show every different indigenous community in the US state of Alaska. So you get a sense of the diversity of language, diversity of cultural views and sections, cultural views and the beliefs around water. Highly, highly distributed. We're talking about 200 plus towns with 1,000 people or more or less. Different language as we discussed, and also extreme, extreme conditions. They literally have to heat the water to maintain flow. A lot of these places are only accessible by plane. It takes 2 to 3 days sometimes to deliver supplies. So the users have to become somewhat of operators because there's not any other complementary assets that can help them maintain their systems. And so our work there is trying to understand how we rewrite water operator manuals to handle that. But the challenges are extreme, just as the climate is. So for example, this happened during the pandemic in Tulasok, Alaska. There was a fire that could not be put out for 3 weeks, and the system went without water for that time. And so how to adapt quickly, right-size projects for this kind of population over thousands and thousands of projects is becoming a true social and even technological frontier for major programs. You can see the same thing for something like Google. The dots you see here are their data centers. By last count, they have 2.5 million servers. That's as of 2016. And as many of us know, Google's main bottom line is targeted ad revenue that is based on algorithms. And those algorithms require water and energy and cost to run. And so as we see here, it takes billions of gallons of water to cool down their servers. And according to a study that was done by some authors recently, and I'll highlight here, you do not need to read all of this, but I just want to highlight a few points. Training a single BERT model, which is their natural language modeling software, takes as much energy as a transatlantic flight just to train it once. Another point, to increase the performance, that's the BLU score that we're mentioning here, for even 2 languages that are close to each other, English to German, it takes about $150,000 in computational time. By the way, the biases that we know that come from training data. So what do I see as different about these programs? This is what I call next-gen programs. They're hyper distributed to the point there's something like this, cloud computing. You could think of this as not just major programs in the ground, but major programs through the air. Very little of this major program is actually physical, the servers, the broadband, but all the wireless technology and connectivity is what drives it. And if any part goes down, it can affect the entire system, all the way to something that's distributed but hyper local. So think of a solar grid, such as that we see in Zambia here. This kind of system, as the communities build more power, they need to be able to connect to other power sources. So how do you connect these kind of systems is an interesting challenge. So to kind of summarize in terms of where we're at, and then I'll talk about a couple of examples of where I think we can go. We're talking about historically major programs have been centralized. You have a variety of organizations, but they usually converge on one site, a big project like a bridge, road, etc. We're now dealing with distributed decentralized kind of projects, 1,000 different projects spread across different contexts. The historic mission is, how do I take a single project and scale it for billions of people? Now we're thinking more like right sizing. How do I take 1,000 projects and make them each possible for 1,000 people across different contexts, extreme conditions, and environments? Often when we look at major programs, we think, how do we replicate the outputs of a prior project on budget, on time? I think when we're starting to deal with the fact that contexts are different, we're now trying to replicate methods that can be deployed and are flexible to different kinds of contexts. And the process by which to do major programs, especially in one area, is a standardized process, which is replicating kind of the same kind of products and fittings and parts. Now, if you're trying to tailor them to different contexts with different learnings, you may need to tweak them a bit for that context. So how do I think this works? I look at kind of two ways things go forward. One is around scaffolding, the kind of collaborative technologies and models you need now to actually collaborate across these distributed programs. And then secondly, something very important to me, but I think is increasingly important, hopefully to others in major programs, is the ability to use our prior major programs to detect who has been missing in the process historically. So how do we now retrofit or repurpose our existing major programs to address those who have historically been excluded? So to give some examples, let's take an instance of climate change. We need to hit net zero by 2050, half emissions by 2030, 2035. But a major program takes 10 to 15 years. So really, the major programs that are online now have to have emissions now. And how do you do that when climate is increasingly unpredictable, when you're trying to envision what a flood will look like on your major program 15 years from now, how fluctuations in temperature will look like 15 years from now? And now we get into things like augmented reality to help visualize that. Digital twins at a more systems level. Digital twins, for those who may not know, are virtual instantiations of the physical. There's even behavioral twins now looking at synthetic populations. But this doesn't even need to be that high tech. So for example, Arup, when they developed their water cube, they use a collaborative technology akin to Slack so that every organization knows who knows what, knows who is responsible for what. And that led to a variety of savings. They were able to stay on budget, on time. Even less low tech, if we look at the case of Nicaragua here, when they were trying to help their dairy farmers go from subsistence farming to more formal scaled kind of farming models, which needed certain quality control, et cetera, to help farmers visualize what that could be, they actually developed model farms that shows how you would go by ISO quality standards, how you would set up your livestock and the like. And this is one of those model farms. So we can go through a variety of examples, but I want to give some examples of what's happened in China. I'll give one example of how they experiment. And we're going to go through the kind of work I've done is I've looked at how scaffolds are intermediaries, how they connect public and private actors to help coordinate on a single project. Scaffolding as developing the possible, especially if you're trying to upgrade the knowledge of entrepreneurs who could deploy this. You need to be able to demonstrate how scientific breakthroughs can work in the market. And finally, how you can experiment along new frontiers. And that's where we're going to focus on today, is the experimentation. So why do I focus on China? Their innovation system has caught up quite a bit to the US. This is of 2016. You can see that the output is converging to that of the US. It's almost at parity now, as well as the funding, right? And why I like the case of China is that historically we've focused on incentives around innovation. So how do I get research scientists to feel it's in their interest to patent, to disseminate their knowledge to markets? But that assumes that every individual scientist or entrepreneur has the requisite knowledge to do that. And in a lot of contexts, it's not trivial to assume that someone has the adequate technology. So for example, if I want to create solar panels, it doesn't matter how many incentives I give for the business to create solar panels. If I know nothing about photovoltaics or other kinds of solar systems, it may be difficult, solar energy systems, it's difficult for me to do that. And so they spend a lot of time focusing on the institutional infrastructure, how organizations can coordinate to make those gaps filled. And so I'm going to focus here on just the experimentation part. we're going to study the Chinese drone industry here. So this graph in 2013, that vertical line that you see, that's when the market was recognized in China for drones. And prior to that, you notice there was a lot of areas that had infrastructure to prepare for that. So even prior to the recognition of this market, there was already infrastructure put in place to help experiment. Now, why do I focus on China and drones? Is that, many would still believe that China is a quote unquote developing country, yet they're the leader in a highly innovative new market, which is drones. 6 of the 10 leading firms in drones are actually in China. And you can see it's quite distributed. There's some clusters around some specific cities, but some wide distribution across the country. And we'll look into why that is. So in terms of inputs to the market, we can think of markets as having inputs and outputs. So inputs would be, what are the components I need to make the technology? So in this case, these are all the components needed for drones: motors, cameras, controllers, etc. And what we found is, if we take the same number of drone industry firms, this was done through really great work from a PhD student that led this project, who scraped all the drone firms from the 2 leading drone sites. And what we found is, if we look at where the aerospace schools are sorted, that's where the clustering happens. So the blue dots are where the biggest aerospace schools are in the country. And that's where you see a lot more input technology, where they're building the components, iterating with scientists and engineers to develop those technologies to make the drones performance parameters possible. But that doesn't necessarily find market fit. So there's a reason why in China they focus on agriculture, because there's a set of agricultural science parks whose entire job is to take technology and find agricultural applications. And in fact, some of them were even able to negotiate airspace to test this stuff. And so if we go back to the picture of all the drone firms founded across the country, you can see that the spread is done from science parks. So they're actually able to look at where the arable land is and directly experiment and iterate to develop the outputs, especially in application around precision agriculture. So this is how collaborative technology, even organizations themselves, can coordinate that distribution. How then can we deal with some historical issues that we've had with major programs that some have been left behind? So for this kind of work, I developed some kind of idea that I call sensing. So the idea here is to take insights from the sociology of infrastructure as well as urban studies that actually uses configurations of infrastructure to understand social patterns. So in this area here, what you see is, on the top part of this picture, the one that says 1, 2, 3, 4, they're actually split out by what Rick Granis calls non-trivial streets. Non-trivial here means automobiles. So when you usually have automobiles through a passageway, there's very little pedestrian crossing. On the panel below, the below part, you can start seeing the picture filled out with what is called trivial streets, which is those that you can walk on, pedestrian ways. And you can see, while there's a lot of trivial streets connecting 1 and 3 and 2 and 4, there's very few connecting 1 and 2 and 3 and 4. And what he shows is, like, looking at just where the pedestrian walkways are, you can see why 1 and 2 don't talk with each other, kind of segregated, as well as 3 and 4. And my thought was, instead of using that as the end, why don't we use that as a method to detect where gaps can be? So if we blow this up to an entire city, we can start seeing potentially there's gaps in the cities that we can use our old infrastructure systems to detect. Now, why do I do this? Most of the work at this moment has been, as we understand, is retrospective. So in fact, when we look at natural disasters, such as the heat wave in Chicago that Eric Klinenberg looked at, he argues that these disasters are autopsies of exclusion or isolation in society. But autopsy, for those of you who are in the medical space, is a post-mortem analysis. It's nothing you can do in the moment. So my attempt here to flip this idea on its head is to see, can we use the existing networks to make me do more of what's called biopsies, quick sampling to then help us detect future exclusion. And just to show you, to put this to life, how closely this happens. This is Sao Paulo in Brazil. You can see on the right, there is high-rise buildings, and on the left are favelas. And notice right in the middle, there's actually a street that's basically an automobile street. So it's very likely that the people in the high-rise have no idea of the concerns literally across the street from them. To make this even more immediate, this is the Peabody Estate in London. Again, you see on the outside of this, you see, again, mainly automobile streets. The top part of this picture, the top building here, the U shape above, is actually privately owned housing. On the bottom is affordable housing. And there's literally, even in the gardening, if you see that green wall, that's actually cuts through it to the point that those in the affordable housing, you couldn't even use the common shared playground in the middle, while the private owners could. And I don't even think the private owners even knew this. This is how immediate and close this is. So to show you some examples on a more city level basis, I'm going to look at US bridge systems and electricity systems. So I'll start with the bridge systems. The reason we're interested in bridges is that that is one way in which divides happen historically in the context of the United States. And what we're particularly interested in is underclearances. So the arrow that you see here is the lowest point of the bottom of the bridge to the bottom to the road that's right below it. That's what's called an underclearance. Now, why do we care about this? Is because if bridges are too low in their terms of their clearance, buses can't get through, trucks can't get through, which means communities can't access goods and services or even get from point A to B. And what we see is a tragic pattern, tragic association. So what you see here in this graph, to the left of that zero line that's vertical means you are less associated with a new bridge. So you can see a variety of different demographics are actually less associated with a new bridge. In this context, it's the Commonwealth of Pennsylvania. And even if they get a bridge, it's usually a restrictive one, meaning it's one that goes less than 14 feet. And so the question then becomes, how do you address this? How do you deal with this issue? Right. Another one is electricity systems. This is in the context of India. This will be my final example. And so the assumption is, in this context, what we're interested in is the assumption is, and again, this is in the context of this situation, which was in this area, which is India. There's no normative assumption being made as to whether this is the appropriate gender roles. This is simply understanding that the context we're in have these roles. And the role is as such that in this context, women tended to be focused a lot more on tasks in the house. Not every woman, but most were. And as a result, the argument was if we access or give access to electricity, that women could be able to do a lot from home instead of having to go out to get fuel for the fire, get water, etc. However, access here is defined as having a grid connection, simply something to plug in. But if you're trying to understand distribution within the household, you need to actually look at usage. Who uses what in the house? So if we consider usage beyond access, do you observe this kind of distribution? And we did a mixed method study starting with a very detailed ethnographic interviewing approach with appliance survey, and then used a household survey data that was more wide across India to kind of look at the generalizability of our results. And we're focused on India as a country. So the reason is that as a country, it's the largest unelectrified population. Sub-Saharan Africa actually has more in terms of region, but in terms of a single country, it's India. And they have wide variation electrification rates. So if you look at this example in India, the green is Gujarat, which is known to have a higher electrification rate. It's considered the model for rural electrification. And in the Northeast in red, you see they have lower electrification rates. So study one was in Gujarat, and study two looked at the generalization of this. So if we look at this graph here, appliance access is in peach. That's what is actually in the house. And in yellow is appliance usage, which is who in the house uses what. And you can see here the appliances that are more frequently used by males, females use this as well, but more frequently by males, you have more of them in the house. And the way we could see this is if we just look at the colors. So the green and the green match, okay? We see the exact opposite with female use appliances. So for those that are less used by men, but more used by females, you see less of them in the house. And again, we can see this if you look at the color pattern, green means more, red means less. You can see the opposite in color. So some could argue that maybe it's because certain kinds of appliances are more expensive for that women want than others. It turns out this happens even with frequently available appliances. So if we look at kitchen versus non-kitchen lights and fans, nearly every house that we looked at had 3+ fans and 3+ fans and lights. So all it would take is simply putting it in the kitchen, which is where the respondents wanted to see it. And you could see again a disparity. So the actual amount of lights and fans in the kitchen, some had, very few even had any at all, were mainly not in the kitchen. So you can see here again. So for those who are men who preferred having them in non-kitchen areas, you see a much higher prevalence of those. And all it required was simply moving the light or fan to the kitchen, and we didn't see that. This is further corroborated by qualitative work. So it turns out, this was pretty stark to us, only 26% of women felt they had the ability to do more of what they wanted to do. In fact, we see this in quotes. Life is easier, but still women are always busy with household work, not as free as men. And this is the beauty of doing ethnographic work. We could even observe nonverbal cues. In some instances, when men even came into the house, the woman respondent stopped talking. Even wealthier women noted that this very interview was not possible without males present. And in fact, to do this work, the first author on this study was a student of mine who had to go on her own with a translator, because to have this kind of dialogue, we couldn't have men present. Then we looked at the generalization of this. So if you look at the household survey we mentioned, even 10 years after getting grid electricity, we see a 5x change in the amount of male versus female appliances. And what was interesting is if we split between female-led households, often these female-led households were widowers or others who had more discretion, you see that if they had the opportunity on the right panel here, that if they had the choice, if women led the household, the head interact with kitchen is what we're looking at here, they would actually put it in the kitchen if they had the choice. While if the female was in a household that was not, they actually would not place it. They couldn't place it in the kitchen. But if they had the choice, they would. So again, we can see potentially the electricity system and the bridge system could help us see, depending on how we measure, where there's areas of exclusion that could then target further assistance and help. Right? So why does this matter? So it turns out in other work, we found that if you have even one new bridge in a city, you actually get a 16% increase in high-tech startup rates. We did a kind of a unique instrumental variable analysis to tease out the direction on this. And so if we connect that to what we talked about before, which is that minority groups are associated with less bridges, they could be systematically being shut out from high growth opportunities simply because they do not have the bridges to benefit or take advantage of that newfound connectivity. We can even look at city planning systems. So in this city planning system here, you can see that we're looking at traffic patterns. And usually an algorithm, what it will do is look at existing patterns to decide how to go about optimizing traffic. And so all the algorithm sees is the road in front of it. Now we know about issues with image recognition and others leading to bias, but what I want to kind of posit to you all is also the physical distribution or uneven distribution of physical infrastructure can also do this. So for instance here, just to bring this to a point here, you can see there's a bridge in the background here. A bus in the background here, and there's only one, right? So what does this mean? Is that from the perspective of the algorithm, the algorithm is assuming this road is not one in which buses want to access, assuming even distribution of all access to routes. And so over time, it will optimize this to not have buses potentially. However, if we look at the studies we talked about before, if there's a restrictive bridge in the distance that's affecting a marginalized community, the buses may not be able to get to this road simply because they cannot access it, right? And so as a result, the issue becomes that we're potentially proliferating bias under the assumption that physical infrastructure is evenly distributed when we know it's not. And so perhaps we need to think about algorithms that look at the distribution of these kind of gaps in our infrastructure system, or what I call social sensors, and weight towards that information so that we don't lose opportunities for buses and other kinds of systems that could be hindered by skews in infrastructure to hinder or to proliferate biases in these kind of systems. And we've been talking a lot about data and the like, but I like to bring in human stories to really understand this. So let's take the case of Raquel Nelson. I bring up Raquel Nelson because for those of you who may not know, I am from Atlanta, Georgia. And so this also is a way to bring kind of home to our audience. So Raquel Nelson is a mother of 3. She usually has to take 3 buses to get home. And this is her route home. So this is Pleasantdale Road in Atlanta, Georgia. Here is where she gets off on the bus. She literally, all she wants to do is cross the street. But because there's no lighting, streetwalk lighting or marked sidewalk, she has to go down all the way down this road to the marked sidewalk, cross it, and come back, right? This adds half a mile to an already existing very long journey. So of course she has 3 kids. AJ is impatient. He wants to go home. He wants to eat. He's tired. He runs away from his mom, gets into the middle of the road, and gets hit by a drunk driver and passes away. Now, why this case got national attention in the US and also international attention is because Raquel Nelson was precedingly charged with homicide for a variety of skewed reasons. It ended up being, dismissed. But the reason I'm bringing this up is because if you look at infrastructure, you can kind of see that there's likely many, many more Raquel Nelsons that have to deal with this. So if you look at infrastructure, just basic sidewalk and lighting, for low-income houses, their streets having that is almost a coin flip. 51% have lighting, 49% have sidewalks. High income, it's over 80% plus. And so you can see how these skews in infrastructure take a direct human toll on lives. Bringing it back to the UK context, this is Grenfell Tower, some of you may know. There was issues with the fire doors. There was combustible materials that weren't to code. And again, a tragedy, but if we blow it up to the systems level, 40% of the social rented sector are minority populations. Even though in the UK, only 14% are minority populations. So you can see a skew of who has to experience this more. Now, why is this so pernicious? When I talk to major program managers every day like yourselves, when these problems are presented, you have very clear ideas of how to address them. And so part of the issues we need to understand are the constraints institutionally and organizationally on you all that do this work. And the way I think of it is the following. You have a social system, and it overlays and it creates a physical system, right? You use the best standards you know at the time, the best understandings, the best people, that you bring as much knowledge that you have at the time to bear. But with physical systems, with infrastructure, they're designed to last a long time. For a bridge, 50 to 70 years. In the interim, social systems change. We realize we missed certain things. We excluded certain people from the negotiating table and the like. And so what we're dealing with, why this is an issue, is that we need to think of our physical infrastructure as relics of social systems that don't exist anymore. So to give an example, here's the case of a bridge from our study in the United States, whereby they realized that they had a kind of labyrinth of roads and structures that were designed to deal with traffic in a certain way at the time that is now recognized as bad for traffic. But the challenge is that this kind of road system has businesses attached to it, gas lines, electrical connections, etc., all locking that into place. To the point that when they wanted to change this, it would have added $2 billion to the project. To the point that even the project managers themselves realized this was a problem, but they could do nothing about it because the costs were so massive to deal with it. And in that small decision to keep this on, even in the new technology, the old footprint still drives it. Closer to Europe, there's some very interesting working papers that basically show if you go back to the road networks from the Roman Empire in 510 AD, they're still highly correlated with where road networks are now. And so you can see how long these last. And so one of the things we need to think about is how we can build more malleable infrastructure systems that both capitalize on the longevity and benefit of infrastructure systems, but reduce the liability that happens as we learn new things and have to change those systems. How do we make essentially these systems relics proof? And so what I want to leave you on my final slide here is tomorrow's major programs are decentralized and distributed. Do not get me wrong. Major infrastructure projects are still massively important and contribute two major program portfolios. But what I'm merely saying is that we need to start thinking beyond that in terms of more decentralized distributed systems. Scaffolding is a potentially way to do it, to upgrade knowledge, to develop collaborative technologies. And sensing is another way to kind of help make these projects more inclusive. And perhaps we can think of how to make these more relics proof. And so with that, I will start taking in questions. I see some of them here. Here is my email. Please do not hesitate to keep in touch. You can connect with me also on LinkedIn. Thank you. So I see we already have some questions. So question one, what are your thoughts on distributed water and sanitation systems? One of the things I'm interested in is particularly where those are being increased in rural areas, mainly for the following issue. If we're here in Oxford, right? So, sorry, here in Oxford. And so one of the things we have to understand is that if I call a plumber right now, they can come to me right away in 10 minutes, 5 minutes, etc. If I'm in a rural area, that can take weeks. And so one of the challenges when you're dealing with distributed systems, especially in extreme environments, is that the user needs to have some sense of operation in order to keep these systems maintained over periods of time. And so that way you can leave some of the more major changes for more regular maintenance that can be scheduled, that can be brought in where that time gap can be addressed. So that's where I'm interested in particular around water and sanitation. And that will need to deal with different cultural understandings of water, different technical understandings of water. And so one of the things we're doing is combining anthropology with civil engineering to try to build training manuals that allow for that and can certify on that. So question two, Daniel, you talked about distributed systems, and these are typically seen in rural areas with trends towards urbanization and increased population density outpacing centralized systems. How could distributed systems work in urban environments? This is really great question. I'll give you a very simple example. One of the issues of where there's strain in urbanization is right now in most cities, in my opinion, you have way more infrastructure need and demand than there is supply of resources. So one of the things we need to think about, and what you could use the equity for is kind of how to target where we should have impact. But secondly, let's take something simple like potholes. Right now in many cities, you call 311 or whatever is the equivalent, you call your city government, and they bring their infrastructure group there to clean some very simple potholes. That distracts or takes away the city group from working on their big bridge project, big road systems. What if you could train local communities to deal with those potholes? It creates new jobs that are high paying. It gives a sense of impact directly to those in the community about their work. And it frees up city systems to actually focus on the bigger projects for which there needs to be more attention. And so in that way, there could be potential opportunities, even within cities where there are some areas of cities, in nearly every city I've seen, pockets of exclusion in terms of not maintaining infrastructure going to those areas. What if you built that as an opportunity for workforce training for local communities to do some of the more kind of common infrastructure tasks that could lead to high paying jobs? And there are some interesting programs working on workforce development to try to do that. And so, when we're talking about distributed, in an urban sense, it can be hyper local, very granular. As opposed to rural, we're thinking about more sparse and wide distances. But distribution can come even at smaller, granular spatial resolution. Question three, is there a risk that the increased use of high-cost technologies such as digital twins alienates some stakeholders who can't afford access to these technologies? This is a brilliant question. It actually, one of the issues that's been happening, and why this issue is happening, is that for digital twin technology, they presume kind of a smart planning system perspective, which is if I put all the data in one place, everybody will use it. So there's a couple of issues. One is if we're using digital, by very nature, it's exclusive. So we need to think about how do we integrate offline or distributed, more micro technology that's more usable to a larger audience. But even more so, secondly, let's take the example of electric vehicles. I want to place charging stations, right? From the perspective of the grid operator, they want to put those charging stations as close to the grid as possible so that they can reliably give power to those charging stations. If I talk to the transport folks, they want it along the transportation route so people can charge and go back on. And these two departments are now asked to interact when you're thinking about a smart planning system to distribute charging infrastructure, right? And so now we even need to think more fundamentally, and this is where I think if you come tomorrow to see some of the closing review and some of the things tomorrow, such as Mariah Beshraugh's work and others, how do we think about competing views of what ought to be done and how do we coordinate them? Historically, our work has thought about keeping these kind of separate and then kind of dynamically going between them. But when you're dealing with a smart planning system with digital twins and others, where all the data now is in a cloud or a lake, you're forcing departments every day in real time to interact. And so how do we compete with these rationalized views will be an interesting way going forward, and also dealing with the exclusion of some areas that don't have access to the digital. How can we make this more an offline input? Question 4, are Western governance and economic systems able to emulate the Chinese industrial champion model? I think there are some ways it can. I think the more generalized point of this is twofold. One, we can't just worry about incentives in the system. We need to also think about being mindful of the knowledge. So in fact, there was actually, what I didn't show in this Chinese study, they did the typical kind of approach, which is making businesses easy to register, lowering it down to lowering the cost of registered capital, and it did nothing on the system. It was once the knowledge came in, was clear, especially when we're trying to get marginalized communities involved. And so in that perspective, point 1 is, don't worry, you can't just worry about incentives, you have to worry about knowledge and infrastructure. And what that knowledge and infrastructure is going to depend on your local needs. Point number 2, which potentially could be interesting, this is where I think there's going to be some restriction. One of the things that makes this work in China is that the Chinese Academy of Sciences, for those of you who may not know, it's equivalent to the ESRC in the UK, or the National Science Foundation in the US, or the European Research Council in the EU. They can actually take equity in firms. So Lenovo is a famous example. Lenovo is a firm that has equity from the Chinese Academy of Sciences. So how to create equity sharing agreements could be an interesting way, but that one I think is limiting in terms of the non-Chinese context, because that requires more larger regulatory and legal discussion and political discussion. But to me, that's less of what's happening as opposed to the first, which is being mindful of the knowledge that is needed and not just the incentives to do the work. Question 5. How important ethics are to major program management, and whether there are any practical ideas for addressing this question. Me personally, I'm absolutely of the view that ethics matter. However, what I'm trying to think about beyond that is how to register that to stakeholders who have to worry about limited resources and the like, and also trying to address exclusion in ethics. So for example, one way I position the equity work, the way I frame it to a lot of city government officials, it's a matter of resilience. So if we define resilience as a strength of your weakest link, often the weakest links are kept in areas that are marginalized and excluded. But what's becoming more important because of the disasters we're dealing with is that these are happening more frequently and within the political life cycle of an official. And so if they're not worrying about maintaining these weak links before they get damaged irreparably, it actually adds more cost. So it's in their interest also financially to do it. To give an example, in Pittsburgh, they recently had a bridge that fell that was in a kind of a fair condition rating. The numbers at the time were that it would be $1 million to rehab it. Now that the bridge has been destroyed, it's now up to $23.5 million. So from the perspective of resilience, it actually is better cost, better business to be ethical and equitable. And so the way I try to frame it is recognizing that we have a moral imperative to do this, but also trying to be pragmatic and recognizing the constraints on the major program managers that have to deal with it, and try to help them develop metrics to target that. Another way we've looked at this is saying, look, you have 1,000 projects and you only can fund 10. Why don't you use equity measures to further target where you made that funding? So it's also as a decision support. So being ethical can actually support in your decisions. In the governance, so question 6, in the governance of future major programs, what is the role of the state? How to reimagine the relation between public and private sector? It's a great question. I think of 3 roles. One is as an intermediary, especially in the kind of context we deal with, where there's a move from centrally planned systems to more private free market kind of systems. How the public and private sector have to coordinate is not trivial. And so having intermediaries that are public-private institutions that connect the two is one way to develop common norms and understandings of how we work together. One is the one I mentioned, which was scaffolding. How do I use the organization to help develop what's possible from the knowledge? How do I build models? Even the startups themselves that come out of it could be models of what you could do with the knowledge. And then third is the experimentation. Now, what I mean by experimentation particularly is looking at technology trajectories that have still not yet been resolved. Right now, if we look at the trend in the literature around the state, it was first state as regulator, that it shouldn't be involved in markets, then state as cultivator, which was the work of Mariana Mazzucato and others. But the cultivator assumes that the technology trajectory is known and is simply incubating that. I'm taking it to the next level around experimentation, which is the fact that we don't, for a lot of technologies like AI, quantum computing, 3D printing, additive manufacturing, even drones, we're not fully clear the possible. And so it's putting governments in a situation where they have to take chances on experimenting into the unknown as well. And so those are kind of three roles that I've identified that the government can help with: experiment in early stage technologies, intermediate between the public and private sector, and develop scaffolding that helps demonstrate higher level knowledge. Regarding any decision-making capability in the context of women does have a direct relation to effective energy realization. Also, can we generalize this with respect to other developing economies? Yep. So we see the same issue with microgrid development in sub-Saharan Africa. I've seen examples in Mali and others. It's even actually in developed countries. So there's a really famous book called More Work for Mother. And what they argued is that when new technologies came in, it actually put, as the punchline says, more work on mother. So we see that mother in this context of women who have kids, obviously. And so we also see some of the problems that can come. So some of the solutions that have been done is to give incentives or policy programs in which women can participate. But when you put that into a patriarchal social structure, what ends up happening is violent reprisals, especially from those who feel their power is undermined. So what we're trying to think about cleverly, hopefully, is finding bottlenecks for the family that helps address some of those issues and see if we can work it within the social system. So an example is for areas that use rice as their main form of staple. You can think of cook stoves, because cook stoves, it turns out with electricity, it's much faster to cook rice than with typical wood stoves. And so if we show how giving more appliances and stuff and appliances and other such things to women in this context where women are in the kitchen, this is not, again, a normative claim of whether that should be the case. It just simply, this is the context. But if people see that, what we're thinking is if we introduce that, potentially there'll be spillovers, because now the whole family sees when everyone can benefit from electricity, then we can start doing other things. And maybe there's spillovers. Maybe they add kitchen fans and lights to make that easier. Maybe they add other appliances because they realize when helping one member of the family, you help all. And if we can bring those kind of things that trigger that, potentially that could be helpful. Let's see. Okay, question 8. As well as using distributed systems, how can users become involved in associated capital markets at a level that's locally accessible? This is really interesting. I think this is an assumption we're having to make, is that a lot of these systems need patient capital. You're talking about organizations that, especially with infrastructure, that get a reliable but not a very high rate of return. So some of the things I've been pondering and thinking about, could we think of historical institutional investors that are responsible for healthcare investments, others? Could they be the ones that invest in this as a way to continue their returns? Sovereign wealth funds, potentially. But if you're also doing more microsystems, potentially scaling a bit, a microfinance model could also be interesting. I'm not sure. We don't have a sense of how to do that yet, but these are some possibilities of how do you balance organizationally the need for a reliable rate of return with patience and with scale of capital. Question 9, you showed an example for future thinking construction technology. Why do you think the sector globally seems resistant to change? My theory is the following, is that usually to get larger scale infrastructure projects, you're usually dealing with larger scale corporations. I think you're going to see later in the panel some ways in which these larger scale corporations are trying to innovate. I think part of the issue too is that, and this comes from old work in sociology, namely Arthur Stinchcombe from the 1950s, where he talks about when you hire people for construction, you're not just hiring the contractor, but their entire subcontractor network. And if you want to change who is the contractor, you then have to negotiate directly with subcontractors, which is really, really difficult. There are some instances that have been done, such as aviation. So for example, Airbus does work with larger scale kind of state level companies like Alenia Aeronautica, Dassault Systems and others, but part of it because they're funded in part by European member states. They've actually directly negotiated with municipalities to ensure the welfare. But this takes a lot of time, and they're also inertial to change. So if you have any kind of platforms, such as any other future Airbus, they usually have the same municipalities involved. As opposed to Boeing, they can plug and play their different subcontractors based on the profit margins. So there is ways to do it, but it requires going down often to the subcontractor network, which can be quite time consuming. And so for some vendors or government suppliers that want to do this, it adds a lot of extra time and cost that has to be planned in. How can new digital infrastructure avoid the risk of corporate capture, e.g. proprietary technologies blocking local development? This is an interesting question. I think it's going to depend on, at least in my opinion, it's going to depend on how open source technologies advance. We see this in some technological areas that companies like Microsoft, some of aspects of Microsoft and others see GitHub and other things as important to cultivate to do more open source technology, mainly in the following reason, is that oftentimes to cultivate this within a hierarchical structure, it can be difficult. And open source allows a flatter hierarchy that allows more experimentation. It's also the reason, for example, why corporations engage in corporate venture capital to kind of seed projects outside the hierarchy. And if it goes well, they bring them in. The degree to which that's applicable is kind of is up for grabs, I think. It depends on certain technologies. I think it's going to be difficult to think about how to do this with large-scale physical infrastructure. But one thing we could potentially see is that if it's highly distributed, then in order for you to have a proprietary technology that works across context, that could be quite difficult to actually get enough scale to make it proprietary. So potentially there could be, with distribution, that could be a protection point to do it, but that's merely a guess. There's no test on that. Okay, final question, and I think we're almost at time. Historically, the role of the major project leader has been seen as critical. What do we know about how to support distributed leadership, i.e. leadership in multiple local contexts that accelerate effective change? This is a lovely question. In fact, in my work on rural water systems in Egypt, one of the things I found, which was quite interesting, is you identify local champions in the community that do it. And often the ones that are most successful is when you identify key female stakeholders. And they're the ones that are able to coordinate this. That's one way. The other way to deal with distributed leadership, Johanna Meyer, and also who you will see in the closing review later, Mark Ventresca, have really interesting work on how village executive councils can be retrofitted to do this, where they have more community-based, coalition-based leadership, where it combines social understandings of water systems with technical. So sometimes you can build it organizationally as a kind of a scaffolding or intermediary structure. And with that, I think I'm already over time at 10:02. It's been really a pleasure, and I'm excited to engage with you all in the next today, as well as the next couple of days going forward, as we think together what ideas could be for the future of major programs. Thank you so much.